Good afternoon, students. Mr. Fugit here. In this video, we're going to be looking at one of the homework questions from homework assignment number 2, which covers over vectors. Specifically, we're going to be looking at, in this video, question number 3, which is the first of a two-part question. So, let's go ahead and get started. I'll read the problem statement for us together. It says this: a truck travels up a hill with a 9-degree incline. The truck has a constant speed of 15 meters per second. What is the horizontal component of the truck's velocity? Now, initially when reading the question, you'll notice there are two different words here we haven't really discussed much in class: speed and velocity. For what we're doing today and for homework number 2, we're going to assume that speed and velocity are essentially the same thing. In the future, when we get heavier into kinematics, we'll talk more about the nuances and differences between them, but for now we'll essentially treat them like the same thing. So what we're looking for here, according to our problem statement, is this. We want to find what's called the horizontal component, which is a word we've seen before. I'll abbreviate COMP. The horizontal component of velocity. That's what we're looking for according to the problem statement. And it's always important for us to pause before we begin working and identify what we're looking for. So, we're given a little bit of information to help us solve for this horizontal component of velocity. We're told that we're traveling at a 9-degree incline at a velocity of 15 meters per second. So what I'm going to do is I'm going to take those two values and I'm going to draw a picture using them. So I'm told I'm traveling at a 9-degree incline, so I'll just arbitrarily draw a vector here. And we're told that our velocity, which I'll call v, my vector symbol, is 15 meters per second. Now I'm told that I'm traveling at a 9-degree angle, so I'll represent that in red, 9 degrees. Now, even though we haven't dealt with velocity before, we've been mostly looking at displacement, we can treat velocity just like any other vector. We can break it down into its components. So more specifically, what I'm going to do here is I'm going to call this horizontal component my velocity in the x, and this vertical component my velocity in the y. And part A here is asking us specifically to look at our velocity in the x direction. So in order to do that, let's come to a new page. So now on our new page, I'm going to redraw my picture from the previous page. I have my velocity vector, which was 15 meters per second, that was v, at a 9-degree angle. Now, in order for us to keep track of this, I'm going to use blue to represent my x component, velocity in the x direction, and I'm going to use red, which you'll see more in the next video, to represent my y component, just so we can keep track of what we're solving for. I also have an angle, which we were told in our problem statement was 9 degrees. So, at this point, we have our overall velocity vector, which we're modeling effectively as the hypotenuse of our right triangle. Then we have our x component, horizontal, and our y component, our vertical. Now, according to what we have, our angle and our hypotenuse, we're asked to solve for our x component, which is effectively going to be the adjacent side of our triangle. From the trig functions that we've been using, the function that represents the adjacent side to our hypotenuse is going to be the cosine function. So I'm going to write out my expression. It should look like this. Cosine of my angle, which is 9 degrees, should be equal to my adjacent side, which is velocity in the x direction, divided by my hypotenuse, which is 15. For now, I'm going to leave the units off just so we can focus on getting the right value. So now, if I want to get my velocity in the x direction by itself, what I'm going to do is I'm going to multiply by 15 on both sides of my equation. So I'll multiply by 15 on the right, and I'll multiply by 15 on the left. What this will do is this will cancel out the value of 15 on the right side. So I'm now going to hopefully get my velocity in the x direction all by itself. So we'll get rid of these values on the right-hand side. And I should now have an expression that helps me represent just my velocity in the x direction. V sub x is equal to 15 times cosine of 9 degrees. Now, when I plug this value in, 15 cosine of 9 degrees which I will plug it in as we go. Here's what I end up with. I get a value for my velocity in the x direction of 14.8. And my units here, remember, are meters per second. Okay? Again, I know the units are something we're not as familiar with, but that's okay. Don't worry too much about the units. We're just going to treat this just like we would any other vector problem. Now, if I look at my answer key, looks like my value should be approximately 14.8, which is exactly what we solved for down here. So at this point, we've now answered the question. We found the horizontal component of our velocity, 14.8. Now, I know some of you all might get a little bit tripped up with the units that are here and the fact that we haven't discussed velocity or speed at really great length. Okay, but I want you to treat them like we have any other vector. Don't worry too much about the units. Apply the process that we've been looking at. If you have any questions, don't hesitate to let me know. And remember, your values are going to differ from the ones that you see in this video. But the process should remain the same. Best of luck.